we've talked about the graph of sine and cosine, and we've talked about how you can make transformations of this thing to move it downwards and scale it upwards or downwards, or lift it up. So if we take a sine or cosine and write it in this form, basically what we're doing is we're making vertical changes to it, because we're looking on the outside of the function, we're changing the range. So all we're doing is changing how it's either being moved vertically or scaled vertically. The question we're going to look at now is what happens if we want to change it horizontally. If I want to make a change horizontally, that's basically changing the input to the function, because that's the domain. And I want to know how I can take this thing and shift it or scale it. Okay? And we're going to find out that those things are intertwined. The basic idea is I'm going to have to look at this and figure out what's going on with a single cycle. If I can work out one single cycle, everything else is going to fall into place, because after that it just repeats. So when I talk about a single cycle, for the sine function, and I go from 0 to 2 pi, it's going to go up and down plus or minus 1. And it's going to go from 0 to 2 pi. Okay? And notice it starts at 0 and then comes back, goes up and down, and then back at 0. If I try to do the same thing for cosine, it's going to look a little different, but it's the same idea. So it's going to go up 1, down 1 for the amplitude. It's going to go from 0 to 2 pi again. But in terms of where it starts at the top, comes all the way down, and then back up. So one full cycle now is of that form. Okay? So if I'm thinking about sine, one full cycle from 0 to 2 pi starts at 0 and goes through one cycle. Cosine starts at 1, decreases, and then goes through one whole cycle like that. And if I want to change what happens in terms of the horizontal scale, then I'm going to change it by going something like this. Oops, that should be a C. Okay. So here, the thing that I'm going to put into it, I'm going to shift it left or right with a C, and then I'm going to scale it or compress it or stretch it, depending on what B is. Okay, so how's that going to work? So if I've got a sine wave versus a cosine wave, I've got to figure out where do the cycles start and end. Okay, and just thinking about this graphically is going to help us. All right, so suppose I have something like that. Okay, then if I want to work with this in terms of being a sine function, then I'm going to find out, oops, that's not going to be good. I need it to start in the middle and start going up, and then go through one whole cycle. So basically I'm just going to focus in on that, and when I look at my sine function, I know as I go from 0 to 2 pi, that it's going to do something like that. Okay? And now, in terms of my amplitude is going to be this distance from the center to the top, also the center to the bottom. Okay. How much I shift up this center, that's going to be how much I shift the whole function. But in terms of what's going on vertically now, so if this is some A to B, I've got to figure out how this is going to go from 0 to 2 pi in terms of my angle theta, and then how much I'm going to shift it there. Okay. If I were to do this now with, instead of this function, or instead of working with a sine function, so here I'm thinking of A sine bx plus c plus d. I have this same thing. Careful here, these are x's, these are y's. And I know I'm being sloppy, but it's a general idea here. So if I got, suppose that's the same thing. if I'm worried about a cosine, if I want to write this as y equals a cosine bx plus c plus d, my full cycle then is going to go from top to top. Okay? And so now, let's see, in terms of the middle, this is being shifted up some d. My amplitude is exactly the same as it is above there. So notice there's no difference in terms of the outputs, in terms of the range, but because this thing is going to be shifted, I've got to now think about this as going from some a to b, and then in terms of my cosine function, I've got to figure out how does this translate to 0 to 2 pi. Okay? So let's look at an example, and maybe that'll make things a little more clear. I know this is a little difficult, but that's why we practice. Okay, so let's look at an example. So I've got a sine wave, so that's telling me something. And it's going to go from -1 up to 7, and it's just going to keep repeating, going up and down between -1 and 7. It's going to have a period of 4. And it's going to hit a max when x equals 2. Okay? So, all right, what does period mean? Period is how long it takes to go through one full cycle. Okay? So let's see if we can draw a picture of this beast. So let's see, it's going to go from 7 to -1. And I'm just going to draw this. It's not going to be good, but let's see. So it has a max at x equals 2, and then it's going to go through one full cycle as it goes from 2 to 6, and another full cycle when it goes to 10 and 14. Let's see if I take 2 minus 4. As it goes from here to here, it's going to have one full cycle. As I take another 4 off, it's going to look like this. So as it goes from here to here, it goes through one cycle, here to here, one cycle, one cycle, one cycle, one cycle. Let's see, when x is 2, I know it's going to be a max there. And then at the end, it has to be a max at the end of each full cycle because I know I'm starting at the top. Okay. That means it's going to have a minimum here, right in the middle. So we're at 3. So let's see, so it's going to go something like this. All right. Okay, now, let's see, so now it says a sine wave, so what does that mean? That means it's going to have something of that form. Okay. Now sine, let's see, I want to go wherever that is. Okay. And the idea here is that if I look at this box right there, okay, so this is going to have a length of 4. As it goes from here to here, it's going to go through one full cycle. Okay. What do I have? So it's a sine wave. So if I just look at sine by itself, if sine goes from 0 to 2 pi, it's going to have one full cycle like that. So here's what I'm going to do. First thing I'm going to do is I'm going to figure out A and D. I think that's a little easier to sort out. Okay. So I'm going to do the vertical first, and then the horizontal I'm going to do second, because I think that's a little harder. It's always good to start with the easier part, get a feel for the problem, make some traction. So let's see. When I'm up at the top, sine has to equal 1. Okay, so I'm going to be careful. I'm going to assume that A is greater than 0. I don't know if D is positive or negative. I suspect it's going to be positive because it looks like the whole thing is shifted up. Let's see, so when sine is positive 1, that means I'm going to be way up here at the top. So that means that A plus D has to equal 7. When I'm down here at the bottom, I know that's going to be minus 1. What happens at the bottom? At the bottom, sine is negative 1, so I know I'm going to have minus A plus D. Okay, so now notice here I've got two equations, two unknowns. If I add this equation to this thing, I get A plus a negative A is 0, D plus D is 2D, 7 plus negative 1 is 6, so my D is 3. What's A? A is going to be 7 minus D, so 7 minus 3 is 4. Okay, so now I know that A equals 4, D equals 3. Okay, so let's keep that in the background. Does that make sense? So this is going a difference of 8 from top to bottom, and I know I'm going to have to go, let's see, I have to go up half that distance from the middle, so that's going to be 4, so that makes sense. And should it be 3? 3 plus 4 is 7. Okay, so I feel good about that. Let's do the horizontal now. Now this is going to be a little bit trickier. So what do I know here? I know, let's see, right here, I know that that's x equals 2. And from here, I know that at the top, I know that the value of theta has to be pi over 2. So let me come back and look at this thing. I'm going to think of this thing as my angle. And when I give it an angle of pi over 2, I know I'm going to be up here at the top. So when x equals 2, the angle has to be pi over 2. So let's see, so pi over 2, that's my angle, is going to be b times 2 plus c. Okay, when I'm down here, so now let's see, this is going to have to be halfway between here. Right, so if I know the bottom is going to be halfway between the two tops, so that's got to be at 4, because that's halfway between 2 and 6. So let's see, at the bottom here, that's going to be 3 pi over 2. So sine of 3 pi over 2 is negative 1. So when the angle is 3 pi over 2, I have to be down here at the bottom. That's going to be b times 4 plus c. Okay. Notice I've got two equations, two unknowns. So let's do this. Let me solve this for c and then plug that result into here and then solve for b. So if I subtract 2b from both sides, so I'm going to subtract 2b. There's my value of c, so I can plug that in here. So that's b times 4 plus pi over 2 minus 2b. Let's see, let me subtract that from both sides. This is going to be 4b minus 2b. 4b's minus 2b's is going to be 2b's left. 3 pi over 2 minus pi over 2 is going to be what? Pi. So my b is pi over 2. So let's see. B is pi over 2. And now I can use this to find out what c is. C is pi over 2 minus 2 times b. So that's what? Pi over 2 minus pi is negative pi over 2. So what does that mean? I come back here, plugging back into that expression, y is 4 sine, what's b is pi over 2, x, c is minus pi over 2, and d is 3. Okay? So the key thing here is to very carefully lay out your picture, separate the vertical from the horizontal. So in this case, A and D tell me what happens in terms of stretching and shifting things vertically. So I focus on getting those by just focusing on what's happening up and down. The inside part here is going to either shift or stretch things horizontally, so I look at that separately, and I got to figure out how do I get one full cycle and compare it to one full cycle here and see what I get. Now notice, in terms of figuring out what these values are, this is not unique. Because this thing repeats itself, I could get a different number here. I could add 2 pi to that, and I still have a valid result. So where I choose to put this box will change what that value is, but that's okay. The key thing is recognizing when you have one full cycle, figuring out what it means in terms of your inputs and solving, and just stay consistent once you've made that decision.